Hey guys, today we are going to review Pythagorean Theorem and special right triangles. So we'll get started here with finding the hypotenuse of this right triangle. Okay, so we've got the two legs squared added together, so 10 squared plus 24 squared equals the hypotenuse squared. So in my calculator, I'm going to type in 10 squared plus 24 squared. And that is 676, so I've got 676 equals x squared. Okay, now that might be a whole number, so I'm just going to try the square root of 676, and that is 26. Okay, so we get a whole number here. Okay, so 26 is my answer for number 1. On number 2, I've got y squared plus 12 squared equals 18 squared. Don't forget the hypotenuse always goes by itself. Okay, so I need to subtract 12 squared from both sides. So I have 18 squared minus 12 squared, and that is 180. So y squared equals 180. Okay, now this time when we do the square root, I don't think we're going to get a whole number. So I'm going to do a factor tree here. I've got 18 times 10, and 18 is 9 times 2, then 9 is 3 times 3, so I have a pair of 3's. 10 is 2 times 5, and that gives me a pair of 2's. The pairs come out, but they come out as a single, so I've got a 3 and a 2 coming out. And then the square root of 5, that's the only leftover at the bottom of a branch. So my final answer is 6 times the square root of 5. All right, so if I have the lengths 2, 3, and 4, what kind of triangle will that give me? So I have 2 squared plus 3 squared, and I need to compare that to 4 squared. So 2 squared plus 3 squared, that's 13. And 4 squared is 16. 13 is less than 16. When a squared plus b squared is less than c squared, the triangle is obtuse. Okay, next one, I have 5 squared plus 5 times the square root of 3 squared, and I'll compare that to 10 squared. So that's 25 plus, and then 5 root 3 squared. There's no plus in between the 5 and the root 3, so it's a single term, so I can just square both factors of it. 5 squared is 25, times the square root of 3 squared is 3. Okay, so that's 25 plus 25 times 3, which is 75. 25 plus 75 is 100. 10 squared is 100. These are equal. That means this is a right triangle. Okay, now in this case, we can give the exact angle measures for this one. Okay, so I've got a right triangle. The shortest side is 5. The longest is exactly 2 times that length. And the medium side is exactly the short side times the square root of 3. That is what happens in a 30, 60, 90 triangle. So the angles of this particular triangle are 30, 60, and 90. Okay, then last in this section we have 10 squared plus 13 squared compared to 15 squared. Okay, so 10 squared plus 13 squared. That is 269. 15 squared is 225. A squared plus b squared is greater than c squared. That means this triangle is an acute triangle. Okay, then our special right triangles. First we have a 30, 60, 90. The short leg is to 1 as the longest side. The hypotenuse is to 2, and the medium side, the longer leg, is to the square root of 3. So I have x is to the square root of 3 as 18 is to 2. I can multiply this across, so I get x equals 18 root 3 over 2. And 18 is divisible by 2. 2 goes into 18 9 times, so I have 9 times the square root of 3 as my final answer. In a 45, 45, 90, the legs are to 1 as the hypotenuse is to the square root of 2. So y is to the square root of 2 as 9 is to 1. I can multiply square root of 2 across, and I get y equals 9 times the square root of 2, and that's over 1, but I don't need to write over 1. So my final answer is 9 times the square root of 2. Another 45, 45, 90, in which the leg is to 1 as the hypotenuse is to the square root of 2. So z is to 1 as 16 is to the square root of 2. Okay, now z over 1 is z, so I don't need to change anything there. I don't need to multiply across, but I do need to multiply top and bottom by the square root of 2 so that I can rationalize the denominator. So I get z equals 16 times the square root of 2 over 2. And 16 is divisible by 2, so I get 8 times the square root of 2 as my final answer. And our last one, we have a 30, 60, 90. The shorter leg is to 1 as the hypotenuse is to 2, and the longer leg is to the square root of 3. So L is to 2, as 15 is to the square root of 3. So I'll multiply this across. I get L equals 30 over the square root of 3. And now I need to rationalize the denominator. So square root of 3 on top and on bottom. So I get L is 30 times the square root of 3 over 3. And 30 is divisible by 3 10 times, so I get 10 times the square root of 3.